Hello and welcome to another discussion of a circuit containing a voltage source and several resistors. In this particular case, the circuit that we're going to discuss contains a voltage source V1 with 10 volt, 3 parallel resistors, R1 200 ohm, R2 300 ohms, R4 or rather R3 400 ohms, and they are parallel with R4, which is a 100 ohm resistor. We want to solve this circuit. In particular, we want to know the currents in the parallel resistors over here, R1, R2 and R3. So let's start with R1, R2 and R3, and we can determine the equivalent resistance, which we will name R equivalent, R1, R2, R3. And since R1, R2 and R3 are parallel, we can say 1 over R equivalent R1, R2, R3 is equal to 1 over R1 plus 1 over R2 plus 1 over R3. Now if we substitute the values for the resistors, we get 1 over 200 ohm, 1 over 300 ohm, and 1 over 400 ohm. And if we calculate the inverse thereof, we get 5.0 times 10 to the minus 3 plus 3.33 times 10 to the minus 3 plus 2.5 times 10 to the minus 3, which is, if we add them up, gives us 10.83 times 10 to the minus 3. But of course we want the inverse of this value, and if we obtain the inverse of 10.83 times 10 to the minus 3, we get a value of the equivalent resistance of R1, R2, R3, which is 92.31 ohm. We can now redraw the circuit by replacing R1, R2 and R3 with R equivalent R1 to 3 as follows. And here we can see in figure 2, R1 and R2 and R3 is replaced with R equivalent R1, R2, R3. And here it is shown in the circuit where initially the parallel resistors were. We have now the equivalent resistance, 92.31 ohms, and we still have our R400 ohms, and we still have V1 as 10 volts. Now we can calculate the total resistance of the whole of the circuit as R4 and R equivalent R1, R2, R3 are in series. We can calculate the total resistance by simply adding R4 and R equivalent R1, R2, R3. It can thus be said that R total, here abbreviated as RTOT, is equal to R4 plus the equivalent resistance R1, R2, R3, and that is 100 ohms plus 92.31 ohms, which gives us R total as 192.31 ohms. Now we can also calculate the total current in the circuit, I total, or abbreviated here as ITOT. It can thus be said that I total is equal to V1 divided by R total, which is 10 volts V1, and R total, which we calculated here as 192.31 ohms, and this gives us 52 times 10 to the minus 3 amps, or it can be said that I total is equal to 52 milliamps. So shown here in figure 3 is the circuit with the total current of 52 milliamps. Here we can see the total current of 52 milliamps is indicated in this figure in red. But remember, I total of 52 milliamps also flows through this resistor, R equivalent R1, R2, R3. So we can calculate the voltage drop across this resistor, and which we will call V equivalent R1, R2, R3. So we can say V equivalent R1, R2, R3 equals the total current times R equivalent R1, R2, R3, which is 52 milliamp times 92.31 ohms, which is 4.8 volts. So we can say the equivalent voltage, R equivalent R1, R2, R3 is equal to 4.8 volts. But remember, V equal R1, R2, R3 equal to 4.8 volt, here indicated in figure 4. Let me just get this laser thingy. Is also the voltage drop across resistor R1, R2 and R3. And we've already calculated that these three parallel resistance is equal to 92.31 ohm. So we can calculate the current in each of these three resistors, and we can say the current in resistor R1, which we denote as IR1, is equal to V equal R1, R2, R3 divided by R1, which is 4.8 volt, as indicated here, divided by R1, which is 200 ohms, and that gives us 24 milliamps. In a similar way, the current through resistor R2 is once again also 4.8 volts, which is V equal R1, R2, R3 divided by R2, which is 300 ohms, and that gives us 16 milliamps. And I, or the current through resistor R4, is once again the equal voltage across the parallel resistors, which is equal V equal R1, R2, R3 divided by R3, which is 400 ohms, which again gives us 4.8 volt divided by 400 ohms, gives us 12 milliamps. Okay, so I've just repeated circuit here in figure 4, which shows us that the current calculated in resistor R1 is 24 milliamps, the current in resistor R2 is 16 milliamp, and the current in resistor R3 is 12 milliamps. So if we can say that I total is current in the resistor 1 plus the current in the resistor 2 plus the current in the resistor 3, which is 24 milliamps plus 16 milliamps plus 12 milliamps, which is 52 milliamps, which is correct as we calculated that previously and indicated I total as 52 milliamp. Now we can also calculate the voltage drop across resistor R4, which we denote as VR4, is equal to 10 volts minus that 4.8 volt, that equivalent voltage V equal R1, R2, R3, which is 10 volts minus 4.8, which gives us 5.2 volts. So we can say the voltage drop across the resistor R4 is 5.2 volts. Yes, we have also simulated the circuit in LTspice, So it will be interesting to see what we get. So let's first run the simulation. And what we're going to do first is measure the current in resistor R4. And we're going to click here, current in R4. And here we get this little window. And it displays the current at 52 milliamps. Now let's measure the current in R1 and current in R1. That's 24 milliamps, and that complies with our calculations. Now for the current in R2, and that is 16 milliamps, and that also complies with our calculations. And now the current in R3, measure in R3, and that's 12 milliamps, and that also complies with our calculations. Now let's measure the voltage drop across the resistor R4. That's over here, and that's 5,1999998 volts, which is 5,2 volts, which also complies with our calculations. And now let's measure the voltage drop across the parallel resistors, and that's like so, and that is that node over here, and that's 4.8 volt, exactly, also complies with our calculations. So everything seems fine. Thank you for watching. All the links are in the description below. Give this video a thumbs up. Click the subscribe button. Goodbye.